something happened in the early hours of the morning that shouldn't have been possible. At 3:15 a.m., a $100 million strategic missile launcher, one of the most protected systems in Russia's arsenal, was taken offline in less than a minute. Not by jets, not by missiles, but by 4 tiny FPV drones that cost less than a weekend road trip. For weeks, Ukrainian reconnaissance teams had watched the site from a distance, waiting for a moment that almost never comes. And then it happened. The silo doors began to lift for a simple diagnostic test, a routine procedure that accidentally exposed the launcher's most fragile components to the open night air. What followed was a 47-second chain reaction that no one on the ground was prepared for. Because while the defenders thought they were controlling the timing, someone else was controlling the opportunity. And what unfolded next didn't just disable a launcher. It revealed a new kind of battlefield math, one where the cheapest machines can force the most expensive systems to their knees. The first clue that something was off came long before anything exploded. For 2 days straight, Ukrainian reconnaissance teams kept their eyes locked on the Kapistan Yar test range. Nothing moved. Nothing changed. And then, just after 3 a.m., the pattern finally broke. Inside the facility, a Russian engineer initiated a cryogenic pre-chill sequence, standard. Prep for a routine diagnostic. But a diagnostic meant something rare. The silo doors would open, and when those doors opened, the launcher's hidden plumbing, cables, and cryogenic lines would be completely exposed. To most people, that's boring technical work. To the teams watching from miles away, it was the moment they'd been waiting 48 hours for. Ukrainian military intelligence had already intercepted data hinting that this wasn't a launch, just a checkup. And a checkup meant vulnerability. Within minutes, the SBU and an SSRU Special Operations unit locked in a plan to hit the site at the exact moment it was most fragile, because once those massive doors started sliding apart, the countdown had begun, and the defenders had no idea that their quiet diagnostic was about to turn into a perfect opening for an attack. The second drone, OSA-2, rose higher than it should have, stretching its radar profile to look like something worth shooting at, and the defenders fell for it instantly. A nearby long-range system answered with a missile worth millions, obliterating the tiny drone in a flash. To the defenders, it was a clean interception. To the attackers, it was priceless. Both the main jammer and the long-range shield had just exposed themselves, burning time and attention on decoys that cost almost nothing. That tiny window, just a few seconds, was all the remaining drones needed. OSA-3 and OSA-4 slipped into the inner ring of defenses, the zone designed to stop anything that got too close. And that's where things got dangerous fast. OSA-4 came out of its spiral barely holding together, but perfectly aligned with a vulnerable cryogenic line exposed under the open silo doors. In that moment, the drone didn't need to be stable. It just needed to hit its mark. And it did. The shaped charge punched through a 5-inch, pipe-carrying super-cold refrigerant. Instantly, liquid nitrogen spilled across the surrounding hardware, triggering a violent thermal shock. Metal contracted unevenly. Welds cracked. Circuit boards failed in a chain reaction no one on the ground could stop. Within seconds, a burst inside the launcher's conventional components twisted the massive structure into a warped column of steel. Sensors registered a brief seismic blip. Communications from the site went silent, and the air defenses that had been guarding the region lost a critical part of their coverage. What began as a routine diagnostic ended as a collapsed launcher, all inside 47 seconds. While crews were still trying to understand what happened at the silo, another operation was already in motion miles away. This time, the target wasn't a fixed launcher. It was a $10 million electronic warfare vehicle, moving with a convoy. Oddly enough, the entire setup started with a soldier's casual social media post. Ukrainian analysts pulled the GPS data hidden in the video and built a precise location without sending a single signal back toward the convoy. At 3:30 a.m., the deception opened. High above the tree line, jet-powered Banshee decoys climbed and broadcast a fighter-like signature, forcing radar operators to look up. At the same time, a swarm of low-flying FPVs hugged the terrain, slipping forward on silent, preloaded routes. When the convoy's air defenses finally reacted and shot down some of the decoys, they revealed exactly how their systems were scanning. And that single burst of information was all the attackers needed to tighten the trap. Once the convoy fired on the decoys, its entire radar pattern lit up like a map. Ukrainian electronic teams captured the emissions, and within seconds, a designated digital sniper flooded the EW vehicle's receiver with interference, blinding the node that was supposed to protect the whole column. The FPV swarm shifted into silent mode. No signals, no chatter, just inertial guidance and stored imagery. A few drones peeled off to deal with infantry who had exposed their positions by firing or jamming. Others kept pushing toward the primary truck. A supporting aircraft arrived to help the defenders, cueing another missile shot. But one of the lead drones deployed a tiny radar enhancer that pulled the missile off track before detonating far from the group. With the last obstacles scrambling, 6 FPVs closed in on the EW vehicle. Using the antenna's visual pattern as their final reference, the lead drone burst inside the enclosure, triggering a small fragmentation blast that disabled the system outright. The convoy's radios went silent. Coordination broke, and every armored unit around them suddenly found itself exposed. By dawn, both strikes told the same story. Tiny, low-cost drones had forced some of the most expensive defenses on the field to react, reveal, and ultimately fail. None of it relied on heavy firepower. It came down to timing, distraction, and exploiting seconds the defenders didn't think mattered. A handful of drones worth a few $1,000s disabled a launcher valued in the tens of millions. A small swarm took out a mobile EW system that usually shields an entire armored column. And every reaction from the defenders, every missile, every jammer, every radar sweep, gave the attackers even more data to refine the next strike. The real damage wasn't just twisted metal on the ground, it was the sudden gaps in coverage, the forced redeployments, and the uncomfortable question hanging over every command center. If seconds and cheap drones can tip the scales today, what happens when both sides redesign their defenses around those seconds? What happened that night wasn't just a pair of successful strikes. It was a preview of a battlefield that's changing faster than anyone expected. Expensive shields cracked under pressure from machines that cost less than the fuel used to intercept them. Sensors meant to protect entire regions were blinded, tricked, or overloaded by tools simple enough to hide in a trunk. And the real impact isn't measured in explosions. It's measured in delay, confusion, and the sudden scramble to fill the holes left behind. Because once a system designed to guard miles of airspace goes silent, everything around it has to shift. These two operations didn't just destroy equipment. They forced a rethink of how defenses work, how fast they react, and how easily timing can flip the advantage. And as both sides race to adapt, one question decides the future. In a world where seconds matter more than size, who learns faster?